Office is Bill Cook. They know a lot about these meteors and meteorites, a whole lot more than any of us do. We're all buzzing about it up here because it's something different, it's something cool, and there are so many things we don't know about it, but Bill Cook I'm sure does, and he's on the other end of our line. Good morning to you.
Good morning.
So how unusual is this to have this kind of event like we had last night?
Well, what occurred over Michigan was what we call a superbolide, which is a very bright fireball between the brightness of the full moon and the sun. And you get a superbolide 1 or 2 times per month somewhere on Earth. So for the planet, not so rare. For Michigan, very rare.
Why is that? I mean, why wouldn't we see more, or why do some areas see more? Is there any reason for it?
No, they're pretty much uniformly distributed over the Earth. It's just, people in Michigan are a relatively small part of the Earth's surface. So when you take the size of Michigan compared to the size of the Earth, it's not that big.
No, that's absolutely true. And we do have a few clouds once in a while, so that might also have something to do with it. But spell that for me, bolide.
Bolide is spelled B-O-L-I-D-E. It's the same thing as a fireball. It's just a fancier term to make us sound more sophisticated.
All right. So this bolide, it enters the atmosphere. Did it hit the Earth? Do we know?
What happened last night was you had a piece of an asteroid about 2 yards across hit Earth's atmosphere at 28,000 miles per hour. So at that speed, it starts to burn up, or ablate, as we call it. It loses material, and when it gets low in the atmosphere, the pressure in the front of that piece of rock gets so great, it literally breaks the rock up into pieces, which then are scattered on the ground. So yeah, there are probably meteorites on the ground, pieces of asteroid, just northwest of Detroit.
All right, this is going to sound real simplistic, but if I wanted to go look for it, just, because I want to find a piece of asteroid, it'd be something really different in my life, what would I look for?
You'd look for, if it's a common type of meteorite, we don't know what type it is, but most signs, about 80 to 90%, you would look for rocks that look like charcoal, okay? They will not be hot. They will not be lying in craters. They'll just be lying on the ground. I believe you have snow up there, so they'll probably be lying, there'll be a little pit in the snow. So you'll look for rocks that look like charcoal, feel heavy, and they may be slightly magnetic. So those are the initial things, and then there's a whole series of tests you can do. If you go to the website of Washington University in St. Louis and Google that with meteorite, they give you a whole list of tests you can perform at home to give you an idea of whether or not your rock is a meteorite.
How cool. Now, the other question I've got, Bill Cook, he's the head of NASA's Meteorite Environment Office down in Alabama. Are you in Huntsville, by the way? Are you with Dr. Roy Spencer down there?
I'm in Huntsville, but I don't know Roy Spencer.
All right.
There are several thousand people at Marshall here.
I understand. All right. Now, the other question I've got, they told us that the meteorite bolide that came our way last night caused an earthquake that was 2 on the Richter scale. How does that happen?
Okay. So, like I said, you've got this rock entering the atmosphere, and when the pressure in front of it gets great, it breaks it apart, right? That produces a shock wave similar to an explosion, and that shock wave will travel to the ground, and it will cause the ground to shake a bit. It will also produce the sonic booms and the sounds people heard in the area. So that's not from the rocks hitting the ground, that's from the shock wave when that 2-yard hunk of rock broke apart, and it created a shock wave similar to an explosion.
Yeah. Now, do you track these down there at the Meteorite Environment Office in Alabama? Are you able to see how many are hitting the Earth at any given time?
Well, objects this small, NASA does a very good job at looking for the big rocks, the rocks that are, a mile across that will end civilization as we know it. We know none of those are going to hit for the next several centuries, at least. But the small rocks, when they're 1 or 2 yards across, these things are the color of a pencil lead. So telescopes aren't very good at detecting them. You're looking at something that only reflects 2 to 5% of the light on it. So we generally don't see these small rocks coming, but the atmosphere breaks them up fairly nicely. So the small rocks, we don't see them coming. We pick them up when they enter the atmosphere.
And you get reports like, people are fascinated by it. And
that's correct.
Yeah, exactly. This is just an aside, but you just mentioned the big one. If it ever hit the Earth, it would end civilization as we know it. But you said that's not going to happen for at least several centuries. How do we know that?
Well, because we found over 90% of them, and we can track their orbits fairly precisely. Congress gave NASA that mandate back in the 1990s, and, we've been doing our jobs and keeping track of the big rocks. But I'm a small rock guy. I don't deal with the rocks of doom, as I call them. I deal with the small rocks there. But I go to bed I sleep very comfortably at night, knowing that there's not going to be a big rock smashes.
Well, thank you for reassuring all of us, Bill Cook. I hope you'll come on with us again. I'm just fascinated by this kind of stuff and what you do. And we'd love to check in with you again, as we run into interesting stories along the way. Would that be all right?
That's fine.
We'd love to do that. Thank you so much for your time this morning, and you did a great job explaining it to our audience and the residents of Michigan who saw our bolide. By the way, does it have a name? Do we give these things names?
Well, if we find meteorites on the ground, the meteorites are given a name after the closest town to where we find the meteorites. So you have meteorites like Peekskill, which was found near Peekskill, New York. So if there are meteorites found on the ground, they will be named after the closest town to where we find the rocks.
Cool. All right. Well, we shall see if we have a New Haven meteorite very, very soon. Thanks for being with us, Bill. Really appreciate it. Be well.
No